So let's say we want to write down the number 13. We're not going to be heroic about it and just try and write it straight down. We're going to put some column headings down. And obviously, this is probably one of the hardest things to do. You have to mess about to do this. So, just writing down 13, 128 don't go in, 64 don't, 32 don't, 16 don't, 8 does, leaving us with 5. So we can have a 4, which leaves us with 1. So that's 13. When we're doing positive, wholly positive numbers, what we call unsigned numbers, that is fine. But when we want to represent the sign can be positive or negative. So that's perfect to represent using a bit, because that's what bits are for, representing two values. But unfortunately what we have to do is we have to dedicate one of the bits. Now, the sensible thing that was decided was the most significant bit should be labelled as a sign bit. Okay. If that bit is 0, it means the number is positive. So whenever you get told in a question, oh, this bit pattern represents a signed number held in sign of magnitude, your first thing to do, if you're asked to say what it is, you'll look at the sign bit. So you say, okay, that's positive. So write down a plus. Then read the rest of the number. So you say, oh right, it's plus 13. If I want to represent minus 13, all I do is I change that to a 1, and that's now minus 13. This is sign of magnitude, so this is just mimicking how we write numbers. It is useless to a computer. Alright? So this isn't used to represent data in a computer. It is just an exercise in manipulating binary. That's all it is. So if I was to ask you to write down minus 47, if you're asked to do this and you're told to do it in sign of magnitude, don't write down what 47 is, put the sign bit in first. You've got to remember you're going to lose space. So you go, right, it's negative, put that in straight away. Then, whatever you've got left, write down what your 47 is. So 47 is an easy one because it's going to be not a 32, well you will have a 32 in it, actually. If you were to do the 16, you'd get 48. I'm really rubbish at mental arithmetic, but what I try and do is like go, right, well what's close to that and take it off. So if I was to want 48, I'd do that. So obviously, one less than 48 is going to be that. Okay? However you want to do it, you don't get a calculator, do you? So, I don't know why you don't get a calculator. They can get round it because the calculator is working two's complement. So if they give you a low with sign and magnitude questions, the calculator's not going to help you anyway. Alright, so it's a matter of doing that. What would happen if I asked you to write down the positive number 131? Right, so it's positive, isn't it? So you've got to put the sign bit of 0, and then you've got to write 131 down. There's a problem. It's not possible. Sometimes the answer is not possible. Why is it not possible? We do not have enough bits to represent that value. Okay? So we cannot hold that value in 8 bits. What's the maximum value we're going to be able to write down using sign of magnitude in 8 bits? You'll get asked this.
127.
Excellent. All easy to work out. You just go, right, put them up and whack all those in. That's the biggest we can put. Yeah, 127. It's 1 less than the 128. It's everything but that. So you'll get asked what is the range. So the range for sign of magnitude with 8 bits, don't be surprised if they give you 6 bits and say what's the range. They expect you to be able to just work it out. It's going to be plus 127 all the way to minus 127. Right, I'm going to write a number down and I want you to tell me what this number is. So I'm going to write a negative number down. What number is it? Anything else about the number?
Negative 0.
Yeah, it's negative 0. Well, that doesn't even make sense. All right, so the problem with sign of magnitudes, and one of the reasons why we don't use it, you get this weird representation. So you've lost a number that you could potentially represent. Okay? You could use that pattern to represent another number, but how would you do arithmetic like that? What, special cases? Oh no, you can't be doing that. So sign of magnitude is not massive. You wouldn't say, oh, it's not massively wasteful, but it wastes a bit pattern because that is equivalent to that, effectively, isn't it? If you multiply 0 by a negative number, it is still 0, isn't it? Okay, so that's sign of magnitude. The real way we do it in the computer is something called 2's complement, which is going to freak you out. It still uses the sign bit, but it gets around the problem of minus 0. It's also directly usable in arithmetic. Okay? So whereas with sign of magnitude we had two separate pieces of data, sign and magnitude, 2's complement wraps it all together. Okay? It's easier to show you and get you to do it than it is to explain, to be honest. Right, so let's write down the number 64 in 2's complement, which we often shorten to 2's C. Because no one can be bothered to write big words, not in computing anyway. 2C. If you've got a positive number, it is identical to sign of magnitude. So I go, right, it's positive, write down 64. This is what catches students out. They go, oh, right, okay, that's... Let's say I want to write down minus 64. If you're very clever and you've done this a lot, you can write these directly, but I do not recommend it. There is a technique to it. 2's complement. If we want to write down a negative number, what we do, we write down a positive number first, making sure you put positive sign bit, and then you perform 2's complement, which is a flip process, and then you add 1. Okay, I'll show you the process, but there is a quicker, safer way of doing it. You can do it all in one go. So I'm going to flip all the bits. So I'm negating. So I'm going to go flip, 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 flip. So that's the flip process. So when you're doing these, you must make sure that you say to yourself, right, I've just written down plus 64. That's what I'm going for. Okay, make sure you do annotations on things when you're presenting questions, because you're trying to give that examiner at the end the best chance of marking it properly and not skipping. So we flipped. Now we've got to add 1. Now adding 1 in binary, the easy way of doing that is you move along a bit pattern from the least significant bit until you find a 0. Everything you go past, you make it a 0. You'll see this when you see what the number is. Where you stopped at the 0, you make it a 1, and then just write down the rest of it. Okay? So that is minus 64 in 2's complement, but there's a safer way of doing it. Let's do a different number. Let's do something weird. Minus, I don't know, 27. Right, so I want to write down minus 27. Oops. Don't know what minus 27 looks like in 2's complement, but I know I can write down positive 27. So I'm going to write down positive 27. So no, none of those, none of those. Can I have one of those? 11. That's 8. 8 from 11 leaves 3. What's that? So that is plus 27. Now the better way of flipping is to go from this end and you go flip, 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 flip. When you get to the last one, you leave it as a 1. Okay, so you just work from the most significant end, keep flipping bits until you get to the last one. Leave it as a 1 and then just write whatever was left. Obviously there was no left on this one. So that will be minus 27. So you can see There is if you look at it in like an inverted way, you can read these, but I wouldn't recommend trying to do it. So that doesn't look like the positive 27. The key thing to remember in 2's complement, if you're told this number represents 2's complement, your first thing is to look at the sign bit. If it's a 0 at the front, you say, oh, I can just read it. Positives are easy. Just read it off. If it's got a 1 at the front, then you've got to do 2's complement. Yeah? Have I lost everybody?
Would you reverse it by just taking away 1 and then flipping it?
Yeah, it's a reversible operator. It's a bit like the XOR, flip it. So if I was to do 2's complement on this, right, so if you get given a bit pattern and it's negative and you go, oh crap, they said it was 2's complement, I can't read it. Well, all you do, you just say, right, well, let's just do it with this and see if we get back to the same thing. Well, hopefully we'll, unless I've cocked it up. Right, so you look at it, you see, say, this number represents a signed value in 2's complement. And you go, right, negative. The thing you must do, and I've had so many students not to do this, write down, right, my answer is negative. Because what you do is you get so caught up in the process of like, oh yes, I've done it! And you go, yes, the answer is 27. No, it wasn't, it was minus 27. Don't make that mistake. Right, so it's just the same thing. You flip until you get to the last one, leave it as a 1, everything else just gets written down. So I'm going to flip from here, so no, so you can see straight away it's gone positive. Which, unless you've done something fundamentally massively wrong, you should go from a negative number to a positive number. I don't actually know what you could do to do that wrong, but you might do. Right, so flip, 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 flip. That's the last one, leave it. Hopefully, that is what we start with. Okay? What's amazing is this is built into the CPU. Alright, the CPU just does it. It's a single instruction, it's one of the fastest instructions. Which is handy, because whenever you're doing arithmetic, you're doing this all the time. Right, I'll do one more. Well, let's get used to do one. I'll give you a number, it's in 2's complement. So everyone's happy with the sign of magnitude, that's trivial, isn't it? Right, so I don't know what number we've got here. Right, what number is that? That is a 2's complement number. Do it on a piece of paper. It's a 2's complement number. What number does it represent? So it's obviously negative. Do it on paper. Go through the process. They'll expect to see working on these sort of questions. Anyone got an answer?
Minus 70.
Minus 70? That's a weird number, isn't it? Minus 70. Anyone else concur with that?
Hang on,
Yeah. Oh. Ooh. Minus. Hang on. So we've got minus 70. Oops, big minus
no,
there.
hang on, I got 79.
Minus 79. Any more? Any more guesses? Right, let's go through it and see whether anybody's right. Right. He's 79.
Yeah.
Right.
I don't know.
Right, let's go now. Right, it's 2's complement number. So the thing that you can get stuck into as a trap with these, which to try and trick you up with, is because they said the word 2's complement, you automatically go 2's complement. Got to do the flip and add thing. Only if it's negative. Okay. You're not going to like it when we get onto floating point. Yeah, that's just the builders. They're supposedly repairing the roof. It sounds more like they're trying to dig through to Australia or something. I don't know. They're making a lot of noise. That's all on the video. There you go. Right. So all I'm going to do, I know it's negative, so I'm going to write down my answer's negative wherever I'm going to write my answer down, and then I'm just going to flip. So I'm going to say flip, 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 flip. That is the last one in the pattern, yeah? So I'm going to keep that as a 1. That's the key. And then everything else, just write it down. Everything else should be zeros. Because if that was the last one, everything else.
Then I did mess up.
Right, so reading it off, it's obviously a whole number that is not odd. That's always a quick double check for yourself. Just say, right, if the 0 bit is clear, it must be an even number. And it looks like 64 and 8. So it's minus 72. So nobody was right.
No, I know I was wrong there because I didn't check. I kept flipping.
Oh, right, yeah, so you had a 7. Yeah, no, that makes sense. Yeah, so you can do it either way. Alright, so if I was to flip it the other way, doing the complement and then the add, which is the real process, this is just like a sneaky way of doing it. So I do flip, okay, and then I walk along from the least significant bit looking for the first 0. Change it to a 1, anything I went past, make it a 0. So it's an extra stage. So whatever way you want to do it, doesn't matter, they both see the same result. But basically what we're doing, when we do the flip and stop at the last one, we're basically saying, right, I'm adding the 1 now. Because I know where I need to add it. And that's why we end up the same thing. Okay? So that is all there is to 2's complement. Why are we late, man? Pun?
Broke down.
Broke down? Right, anyone got any questions about that? It's not complicated, but you will make mistakes and you do need some practice on it. There will be something on this on the test we're going to do next week. That's why I wanted to go through it. Okay?